Alright, so today what we're going to talk about is we're going to prove and apply theorems about perpendicular lines. Okay, just remember perpendicular lines are those lines that form right angles. Okay, and this won't be an issue for you at all. Alright, the first thing we need to talk about are perpendicular bisectors. Perpendicular bisectors are exactly what they say. They're perpendicular and they bisect, meaning they have to cut things into two equal parts, and they have to be perpendicular, which means they need to form 90-degree angles. So perpendicular bisectors are usually either a line, and it can be a ray, or a segment bisecting another segment. Okay, it has to bisect another segment because you can't bisect a line because it's infinite. So first off, you have to have a segment. Okay, in order to bisect it, you have to have the midpoint. So you have to find the middle of the segment, which we've talked about how to do. And then to make it perpendicular, you have to just draw it straight down so that it forms 90-degree angles. Now the big thing is that this right here can either be a line, a ray, or a segment. The next concept that we have to talk about is the distance from any point to a line. So the distance from a point to a line is always going to be perpendicular. Okay? That's going to be the shortest distance between them. So when I'm talking about the shortest distance, I'm trying to make a right angle. Okay? If I can't, then I'm not representing the shortest distance. Let me give you an example. If I got a point right here and I have a line right here, the shortest distance from this point right here to this line right here has to make this 90-degree angle. So the shortest distance would have to be somewhere like that. And to kind of look at that and prove that wrong, I mean, look at this. That distance is longer. You know why? Because it forms this right triangle here, which means that would have to be the hypotenuse of that right triangle. So this would have to be greater than this other line. So then using that knowledge, let's take a look at an example. We're going to name the shortest segment from point A, so right here, to this line, BC. Well, the shortest distance, basically all you're looking for, again, is a right angle. So the right angle is right here. So the shortest distance between that is from A to P. So the shortest segment is segment AP. Okay, now we're going to write and solve an inequality for x. Okay. Now I told you before that this is the shortest distance from A to P. That means A to C is larger than A to P. Okay? So that means that we can set up an inequality. If you remember, inequalities are these greater than, less than, or equal to things. Okay? So what we're going to do is we're going to say that x minus 8 has to be bigger than 12. And then all we do is we solve it. So we just add 8 to both sides. And x has to be greater than 20. Okay? So what this means is that if I plug 20 in, or any number above 20 in for x, it will satisfy this situation. Okay, so I want you to try this. Give it a shot. See if you can get it. Okay? Try both of them. I want you to first name the shortest segment from point A to BC, and then I want you to write and solve an inequality for x. So pause the screen, give it a shot, and then come back to me. Okay, so if you're looking at this, we're going to name the shortest segment from point A to BC. That means we're looking for the right angle. You can see the right angle's right here. Okay, shortest segment means right angle, perpendicular. We're going from point A to line BC, so that has to be this segment right here. So my shortest distance is segment AB. Can't forget it. You got to understand that between the shortest distance from a point to a line has to be this right angle. Okay? Alright, now we're going to write and solve an inequality for x. The last problem we did, our x expression was with the larger segment. Right now it's with the shortest segment, so that's going to change some things a little bit. I'll show you. So you may have noticed that x minus 5 is less than 12, and you can go ahead and solve that. So that means x is less than 17. That's true. But what else does this thing have to be bigger than so that it doesn't become negative? Because I mean, I can't start putting negative numbers in here to get x as being, this segment as being a negative distance, because we can't have a negative distance. So it has to be bigger than 0 as well. So x minus 5 has to be greater than 0, which means that x has to also be greater than 5. So we have these two inequalities that we can put together. Therefore, x is actually between 5 and 17. So let me go over that again. Since we actually had the shortest segment as having an expression of x, that means I had to set it up like this, where the shortest segment was less than 12. That's fine, but we also have to make sure we state that this has to be bigger than 0, because if I don't, I'm going to start to get negative distances for AB, and that's not true in geometry. We can't have negative distances in geometry. So I want to go over these theorems, but before I do that, I want you to pause this and make sure you copy them down inside of the theorem sheet that I gave you. Let's look at the first one, 3.4.1. If two intersecting lines form a linear pair of congruent angles, then the two lines are perpendicular. Okay, basically what that means is that if I'm forming a linear pair here, and these two are 90 because they're congruent, then that means they're perpendicular. Okay, it's pretty simple to kind of understand that. This one is important, okay, the perpendicular transversal theorem. So in a plane, if a transversal, right here, is perpendicular to one of these lines, and they're both parallel, then this one has to be a right angle as well. That's basically what it's saying. So again, if the transversal is perpendicular to one of the pair of parallel lines, then the other one has to be perpendicular too. And then if you look at this one, if two coplanar lines are perpendicular to the same line, then those lines are parallel. The difference between these two right here is not much. This one is the reverse, this one is the regular way. So this is if then, this is if P then Q, this is if Q then P. So this is the converse of the perpendicular transversal theorem. If you have questions on these theorems, we'll talk about them tomorrow. Okay, what we're going to do is we're going to try to use those previous theorems to create some equations so that we can solve for x and y. So we're going to do a couple of examples here. So example 1, we're going to find x and y. That's what we're looking for. Alright, so right now I have a set of lines that are going to be parallel to one another. Now if these lines are parallel and this is a right angle, then you should automatically know that right here is going to be a right angle based on one of the theorems. Okay? So what I'm going to give you is I'm going to give you that this is 8y and that this is 7x plus 2y. So what we're going to do is we're trying to find x and y. So if you look, you should know from the perpendicular transversal theorem that this is a right angle as well. And so if this is a right angle, then that means this is 90 degrees too, and so is this. So I can set up two equations with 90 in them. Okay, let me show you. 8y equals 90, because that's 90 degrees, and 7x plus 2y equals 90. Okay, now if you remember, this is a system of equations. Now, there are three ways, right? The first way is graphing, the second way is substitution, and the third way is elimination. Now I don't want to graph ever if I don't have to. Okay, so I'm going to look at substitution or elimination. Now I don't want to eliminate here because if you look at the top equation, 8y plus equals 90, there is no x, so it's going to be hard to eliminate. So I'm going to choose substitution. So what I'm going to do is I'm going to have to switch this first equation around so that I have y by itself. So to do that, I'm going to take 8y equals 90 and I'm going to solve for y. So if you do that, y will equal 11.25. Now I already have y. So to find x, all I have to do is plug it back in to this equation, because the original one doesn't have an x in it. So we're going to plug it back in here for this y so that we can solve for x. So I have 7x plus 2 times 11.25 equals 90. So therefore 7x plus 22.5 equals 90. We're going to subtract 22.5 from both sides. You're going to have 7x equals 67.5. If you divide these two, we're going to just go ahead and round to the nearest hundredth. I'm going to get 9.64. So that's kind of how you're going to do these problems. You're either going to choose substitution or elimination. Okay, but it's based on setting up equations on those theorems. So we started with saying 8y equals 90 because of this 90-degree angle here. We were able to say then that this was 90 because of the perpendicular transversal theorem. And so then I was able to set 7x plus 2y equal to that too. Alright, I'm going to give you another one, and I want you to set up the equations for me, and then we'll look at solving it. Okay, right now we have two lines that are perpendicular to one another. I know that this is 4x plus 2y. And then I know that this one down here is x minus y. Okay, right now I want you to pause the video and then take a second and see if you can figure out how to set up the equations. Okay, so my equation should be, since this is 90, all of these are 90. So I can set up two equations where 4x plus 2y equals 90. If you thought about setting these two things equal to one another, well, that's a good start, but the problem is you have those x's and y's on both sides, and you don't want to do that. Okay, so I have some students want to do that, so just be careful. It's better to have a number equal to something. Okay, so we also know that x minus y equals 90. Now, you should kind of figure out right away that we don't want to use substitution. We'd rather use elimination because I have an x and a y in both of these. But to do that, I have to make them look like something so that I can create some type of cancellation method through adding. I think the easiest one to do is to eliminate the y. To do that, I have to multiply this bottom one by 2. If I do that, then I'll have positive 2y on the top and negative 2y on the bottom, and they'll cancel out. So let's go ahead and distribute that 2. I'm going to rewrite the top, which is 4x plus 2y equals 90, and then I'm going to have 2x minus 2y equals 180. Okay, so what we're going to do then is we're going to add these out. So these are going to go away. I'm going to be left with 6x equals 270. So I'm going to divide by 6 so that I can solve for x, and x is going to equal 45. Okay, you should know not to plug it back into the one you changed, but instead to plug it back into one of these original ones. It's just easier just to do the original one that we haven't changed. So we're going to do 4 times 45 by plugging this 45 back into the x in the original function. So 4 times 45 plus 2y equals 90. Alright, so we got 4 times 45, okay, which is 180, plus 2y equals 90. So you subtract 180 from both sides. You get 2y equals negative 90. That means that y is going to be negative 45. Well, you may say, wait, Hostetler, I can't have a negative number there. I mean, it doesn't make any sense. Well, let's plug it back in and see if it works. Okay? So if I take this 45 and plug it in up here for x, I'll have 4 times 45 plus 2 times negative 45, because that's what y is. When you do this math, you actually get 90, which makes sense since it's supposed to be a 90-degree angle. Now you might go, wait, that doesn't make any sense here. Well, let's check it. If I take 45 and I subtract a negative 45, that does equal 90, because this is the same as adding. So this is kind of how you're going to have to set these problems up. You're going to have to think about it. Do I want to use substitution or do I want to use elimination? Okay. usually you want to use elimination if you have an x and a y in both of the equations. Okay, so we're about done. So what I want to do is I want to wrap up a couple things. First thing I want to say is I hope you enjoy my No Shave November. Second thing is I want to talk about all the stuff that we've talked about so far. Today what we discussed first was perpendicular bisectors. Those are either a segment, a line, or a ray that are both perpendicular and bisecting another segment. Cannot bisect a line because they're infinite. Okay, second thing we talked about was the shortest distance between a point and a line. That is always going to be perpendicular. So what you're looking for is you're looking for right angles. The third thing we discussed was some problems on how to write equations based on 3 theorems that we went over. Make sure you know those 3 theorems, that you have them written down so that you're ready to go tomorrow when we ask questions. All right, y'all. Have a good night.